All right, guys, let's move on to concentration. So we're going to use this example of nitrogen and oxygen to form nitrogen monoxide. So what happens when some nitrogen is added to the above reaction? When nitrogen is added, right, concentration of nitrogen actually increases. True or not? So by your Le Chatelier's principle, right, equilibrium is going to shift to the right, all right, to remove this disturbance, all right? So the final equilibrium will have more NO and less O2 than the initial. Okay, the amount of NO in the new equilibrium is more than the initial, but is less than at the point of addition because of the shift in position. So what happens to the Kc? If you remember, Kc is only affected by temperature. So basically, Kc will have no change numerically. Okay, so the corresponding opposite is going to happen if N2 is removed. Okay, so now instead of increasing, N2 decreases. All right, equilibrium is going to shift left to replace the decrease in N2, and final equilibrium mixture has less of your products and more of your O2. All right, so Kc again, there is no change. Okay, so this is the graphical representation. Sometimes the question is going to give you like a graph, and they will ask you, what has been changed at time t just based on the graph. Okay, so assuming that you do not know that N2 was added, just by looking at this graph and seeing how the equilibrium shifted and how the concentration of the various species has changed, would you be able to know that it is N2 that is being added? All right, it's actually quite simple. When you see a sharp spike in only one of the two reactants, you have to know that it is that particular reactant that's being added, because it's not possible that the volume actually decreased or the pressure was increased, right? Because then O2 would also be impacted. So to see just one of the two reactants changing, it means that something was done to that particular reactant. All right, then subsequently, when you see the amount of product increasing and both the reactant decreasing, you will know that equilibrium has shifted right. Okay, so because of the increase, the disturbance in N2, the equilibrium shifted right to remove this disturbance. All right, so we can actually deduce what has happened just based on the graph. Okay, so what happens if O2 is removed in the above reaction? Okay, the concentration of O2 will decrease. Le Chatelier's principle states that equilibrium will shift to the left, all right, so that we can form more of the O2. All right, so the final equilibrium has less NO and more N2. Okay, what happens when some NO is pumped in? So now we're increasing the product. What happens? Equilibrium again shifts to the left to remove that disturbance, and then the final equilibrium mixture has more of your reactants than the initial equilibrium mixture.